Some remarkable things have happened in Waldenström's macroglobulinemia in the last 2 to 3 years that have truly changed the way we look at this disease. You know, it had been described for almost 70 years, and yet we didn't know what the genetic basis of the disease was. And this was really the reason why we couldn't move forward and develop novel therapies for patients with Waldenström's macroglobulinemia. So we had to rely on what's called hand-me-down therapies, you know, things that we waited for our colleagues in the lymphoma world, myeloma world, to be able to vet out and ultimately, you know, get our hands on these things. So 3 years ago, we reported the discovery of mutation in the MYD88 gene. This is, you know, was a pivotal moment for our field, since over 90% of the patients with Waldenström's actually expressed this mutation. And then subsequent work by us and others ultimately helped identify the important signaling pathway that's triggered by this mutation. Then came also the discovery of the CXCR4 mutation, which is present in about 1/3 of patients with Waldenström's, and this gave us further insight into the disease. And you know, the important outcome of these two discoveries has been the development of the drug ibrutinib. It was very quickly recognized by work that was done in our laboratory that MYD88 triggered, you know, Bruton's tyrosine kinase, BTK. And this is, of course, the target for ibrutinib. And in a short time frame, we were able to translate this into a clinical trial, which received breakthrough status by the FDA, and as you probably know, just recently received FDA approval for the use of ibrutinib in patients with Waldenström's. And this was based on that scientific discovery.